Hello, everyone. Today is Wednesday, 24th of April, 2024, and this is the Kubernetes SIG cluster lifecycle and Kubernetes cluster API office hour meeting. Before starting, a usual reminder that we abide to the CNCF code of conduct. We have an agenda doc. Let me share it. And add the copy link. It's too fast for me. Okay, I will add the link on the Zoom chat. If you don't have access to this document, you have to subscribe to the SIG cluster lifecycle mailing list. And we can get this started. So please add your name to the attendee list. If you have topic and agenda, feel free to add them. And as usual, every week we give a room to new participant, to new attendee to introduce themselves. So if you are not attendee, feel free to raise hand and I will give you room to speak. Great. It seems that today there are no new attendee. Open proposal readout. We don't have open proposal as far as I'm aware too. So we can quickly move to today's discussion topic. And the first one is Adil.
Yes, I wanted to give the update. We did the patch release for 1.7 yesterday. Now we are supporting latest Kubernetes 1.3.0. I think this is wrong. Let me 130. Yeah. Yeah, 130.0. Yes. Yep. Sorry, my bad.
So some question from Adil. So let me take again the opportunity to thank you, the release team, and especially this is the first release for the new release team. And congrats to you all. You did a great job. Thank you, thank you, thank you.
Yep, thanks.
Next up, Stefan.
Yep. Can you open the issue maybe? Sorry, the request. That's not even an issue. Okay, so I don't know who's aware of it, but basically we are publishing images and manifests on after every commit to main and also once per day. This is about the part what we do once per day. So basically every night we build our manifests. So basically those components.yamls and all this stuff. We are tagging images that already exist with a nightly tag. So you have like nightly underscore timestamp and this sort of stuff. Yeah. One thing that we did not perfectly here is basically that we were pushing the manifests into this artifacts.gatestaging cluster API appspot.com GCS bucket. I mean, that already looks a bit suspicious, I would say. What this bucket actually is it's a backing bucket of our container registry that we have in our cluster API community container GCP project. So basically, I guess this bucket was there at some point. Someone thought, hey, why not put a bunch of YAML files in there? But that's really not ideal. So what this PR is doing is basically change the location where we publish to. Can you click on files changed? There should be basically also the new location. So we have a bunch of buckets. One bucket was the one on the left side. The right one is the right one. So we're now publishing basically this bucket. One major difference is that the left one doesn't have retention, but the right one has it. So on the bucket that we're publishing now, every file will be deleted after 60 days. But that is intended in the feature. And I think that makes sense for nightly manifests that we don't have to keep them forever. But basically, if you are integrating against copy main or something, they will be there for 60 days. Afterwards, they're gone. One major reason why we have to move away from the left side is basically that this bucket it's really, really likely that it will go away. So as I was mentioning, it's the backing bucket of our container registry, and the Google Container Registry is deprecated. So there's a new thing called an artifact registry. I think the container registry will go away like May next year or something like that. But yeah, overall, we have to move to the artifact registry. There are no details known at this point how we will move to the artifact registry, because basically, if I got it right, SIG K8s infra will figure out like a plan on how this will work in the community. And then we'll see. But I think it already makes sense to start storing our manifest in the right location so that people can adopt, and it's not just randomly going away at some point. Yeah, so long story, but basically the small change. What I would recommend, there should be a few providers who are doing the same. I know that we just fixed it in vSphere. I know that I saw a Kappa issue. So Kappa, I think also has a PR open to change it. There shouldn't be that many more providers, but yeah. Maybe check your provider if you're also doing this nightly thing, just a bucket. If you're not doing this nightly thing and you want to start doing it, just take a look at our makefile targets and all this stuff and ask in Slack if you need more details. I think it's nice to allow people to basically integrate against your nightly version of your provider.
Damiano?
Yeah, thank you, Stefan, for explaining this. In this regard, yeah, today, thank you to your guidance, I opened PRs for Kappa, AWS with the same change. And I did start a PR for doing nightlies for GCP as well, and to introduce this change for GCP as well. So hopefully soon we can have this change as well in those two providers.
Very nice.
Thank you. Very nice. May I make a question to folks from provider that are here? Is someone of you consuming nightly builds from Kappa in this case?
So what I do know is that Kappa was consuming nightly core Kappa builds like 1 or 2, 3 years ago, ahead of Kappa releases, essentially, because it was just an easy way to pick up latest stuff when we're getting close to release. Nowadays, we have a bunch of RCs and betas, so probably people are using that instead. Yeah, but I mean, it's still useful outside of our beta and RC phases if you want to test against latest.
Okay, Adil?
Yes, we are not using it right now, but we have planned to start using it in our CI. So yeah.
Yeah, that's a good feedback. So I think that agree is good to have them, and also agree that it's good to have them for not for an infinite time. Yeah, thank you. Thanks, Matt. I just also I want to also comment on Chris that he linked the document, the official document from Google Cloud about transition away from container registry to new Artifactory. Yeah, we are aware of this, but we usually the test infra gives some usage recommendation, and they will basically set up Artifactory features. Some of the Artifactory feature in a consistent way across all the projects. So we have to wait before invest too much energy into looking into all the possibility that this new form of Artifactory will give us, because we don't know if we can. We don't know if we can use all of them.
Yeah, I think for community repos, it doesn't make sense to invest basically in a silo. If you want to work on it, definitely makes sense to go to K8s infra and try to help them. I think that would be. I mean, I don't know if they're looking for people who are not that familiar with that stuff today to help out, but if you want to work on that for community repos, it definitely makes sense to do it within K8s infra instead of trying to do our own thing, because you're probably not allowed to do our own thing, which is probably the right way to approach this.
Yeah, and also Christian is opening a issue from test infra where they probably are going to discuss what the communities will be allowed to do. Okay, if there are no further questions, we can move to the next topic from Stefan.
I have one more small point to the first one.
Hmm.
So there's one limitation that we have. So we publish manifests and images with nightly tags and names. We also publish images with a main tag. I think we don't have manifests with a main name, basically, which means if you want to pick up nightly stuff, you have to regularly change your config to own nightly, and then at the latest after 60 days, you have changed again. If there is demand, I think it should be relatively easy to also publish basically main manifests, and you can always integrate literally against main. But yeah, I mean, if there's interest, I mean, I can open an issue anyway, and we can see. I'll do that.
Yeah, good note.
Okay, yeah, next up, can you open that issue?
Sure.
So another thing that probably most people are not aware of. I mean, I wasn't aware of it until we worked on some related feature. So machine deployments have I just called it a revision management feature. I think it's probably there because it's a copy from deployments. So what is that feature actually? So if you look at a machine deployment, there's a field called revision history limit. Revision history limit lets you decide how many old machine sets a machine deployment will keep around. So let's assume you have a machine deployment, you change it over time. Basically, for every bigger change, it will create a new machine set, and then it will have an old machine set. And if you set revision history limit to 5, then it basically will keep 5 machine sets around and will delete all the other ones. I think the idea behind it is that on one side, you can see what your machine deployment looked before, and also you can do rollbacks. All 4 rollbacks are basically a client-side implementation. So basically, you have to how the client-side implementation works, it looks at all the machine sets, it tries to figure out, oh, I want to roll back like to this one, and then it takes the machine set and copies over the machine set over the machine deployment. So that's how the rollback feature works. On a high level, I opened this issue just to start a discussion if we actually need this feature, who is using it for what, and if we should drop it or not. I mean, obviously not within the current API version, but just long term. It has a lot of complexity. It makes it relatively hard to make changes to the machine set controller because we always have to keep in mind that this history thing has to keep working. We really struggled a bit with making in-place mutation of labels and annotations work. It might be even harder to make actual in-place mutation of machines work if we ever want to do that. I know there's a feature group around that. And also it's not very compatible with other things. So on one side, this rollback feature and also the history feature depends on the client-side implementation. So that only works with cluster-cuddle. The corresponding command is cluster-cuddle alpha rollout. So it has been alpha forever, basically. And there is not much interest in improving that or finishing it or anything. So I think after a few years, it also just raised the question, if we have an alpha feature that is still alpha, should that still be around? And then there are some issues in combination with how you use machine deployments. So basically, if you use machine deployments with GitOps, I think it's not really a use case that someone can manually go on the machine deployment with a cluster cuddle and say, oh, I want to roll back to this old machine set. What you would usually do is you would just change your source of truth in Git, and then that's a rolled mechanism. Or you do a Git revert or something like this. But you wouldn't really manually touch the machine deployment for that. With cluster class, it doesn't make any sense because basically cluster class reconciles the entire machine deployment object. There's no way that if you do a rollback on the machines that it actually works. And it only works with machine deployments. So if you want to do if you want to manage your whole thing just with that philosophy that you can do rollbacks and stuff, it will work okay-ish for workers. It won't work for KCP or any other objects that we have. Because it's just not there. Yeah, so feel free to engage on the issue. I'm not in a rush or anything. I just thought maybe that's a piece of tech debt that would be nice to get rid of if it's not highly used.
Lubomir?
Today there was a complaint by somebody that we removed something. Sorry, we don't remove, we changed something in the way infrastructure templates are named. Fabrizio, you were on the ticket.
Yeah, that's independent, I think.
Yeah. The question here is how can this be changed so that we don't break somebody, or is it possible to be deprecated over a period of time, for example?
So the framework that defines the guarantees the project offer is the contract. The API is what we define as a contract. If folks rely on something else just because it's there, they are relying on fragile basis. So
yeah, but I mean that's a different case because that's an actual.
yeah, that's a different case. So
just to mention,
and this is why we are discussing this deprecation here. If deprecation goes on, this is part of the API. We'll follow the API project, the API deprecation rule. So that's it. So I don't think that we have a clear rule about deprecation. We can always improve them, but that is what we have to stick to.
I see. So potentially when the version of the API that supports the revision management is phased out, it will go away.
Yeah, exactly. We have to deprecate a field, and then the next version we can remove it.
yeah,
Thanks.
Yeah, and really the tricky part, as also in the other cases, basically how do we communicate this in a way that the people who actually rely on it actually notice? And I mean, we would again try to do our best. I think concrete, I mean, we can definitely, I mean, I think there's one thing in the API field which relates to this thing, which is the revision history limit, which probably nobody will notice if we put a deprecate on it, but we should when we want to deprecate it. There are also a few annotations that we use to track revision history, but that's probably not very visible. So I think in addition to that, mailing list, release notes, this sort of stuff. And then, yeah, absolutely deprecate in one version, drop it in the next one or something like that.
I personally think release notes are sufficient and they should be the starting point for any upgrade.
Sorry, I didn't understand.
I'm saying that release notes should be the starting point before every upgrade. And if people are not watching release notes, then they can break. In Kubernetes, we have the same problem. People sometimes miss a release note, they then log a ticket for you. Hey, we tripped on this application or whatever, but they actually didn't see the release note, so it's a problem.
Yeah, people reading release notes is problem for another day, I guess.
Yeah. Okay. So if there are no more questions about this topic, I will leave the floor to Mike, which has something to present us.
Cool. Thank you, Fabrizio. Yeah, I will see if my screen share works.
I think that I have to stop sharing first, maybe.
Oh, yeah. Okay. Great. I just tested this previously and like it worked, and now it's not working for some reason. It's always something, right? Are you looking at like my whole desktop or something right now?
We are seeing something to pop up, which is Slack.
Oh,
and some.
It's real awkward looking.
Yes.
okay.
Yeah. Slack plus a lot of black.
Yeah, I this happened before where it gets screwed up and I can't. So I just tested this out on a previous meeting and it didn't work. Let me try quitting and coming back in real quickly.
Yep.
Wait, am I still here, I guess?
You are still here and still now sharing a
That was
black
the most
screen.
awkward. I'm quitting the meeting I've ever seen. Love it.
Wow. All right. This is going to have to be even more awkward. I'm quitting. Apologies. I tested this out previously and it seemed to work, but I guess now it's not working.
Mike, if you have if it is a Google Doc or whatever, and you give me a link, I can share it.
Yeah, let me do that, Fabrizio.
Okay, now it seems that Mike is totally frozen.
I agree. This Zoom has failed me somehow.
Yeah. Do you pass me the link?
You're on mute.
Our Google Doc settings means I can't
Okay.
I can't make it public, but I just sent it to your Gmail address.
Give me a sec. Okay, we should be good. I share again. This. Okay,
Awesome.
it's sure.
Okay. So yeah, this is a proof of concept and the architecture for the Carpenter Cluster API provider. I just want to say, like, this work has basically been inspired by the feature group. So that's where a lot of these designs are coming from. So this is basically a Carpenter overview for people who aren't familiar with Carpenter. I just wanted to kind of get people up to speed. I might use the words autoscaler and auto provisioner interchangeably. I think there's a subtle difference. Like Carpenter, operates functionally to the user. Carpenter seems to do something similar to the cluster autoscaler, but it's slightly different internally, that it's doing auto provisioning as opposed to auto scaling. And kind of what that means is that, instead of setting up node groups, which are, scaled up and down, and they're linked to like specific, instance types and whatnot, Carpenter has knowledge of node pools, which are more kind of like recipes that it can use to understand the shapes and constraints of machines in the node pools. And so what this diagram is kind of showing is two different avenues of behavior within Carpenter. If you have pending pods, that means that the Kubernetes scheduler knows there is a node that could fit that pod, but there isn't enough space for it. So in those cases, Carpenter can just say, all right, well, I see this node already fits that, and can make a request to the underlying provider to say, okay, make me another, something that fits this shape. And it should be relatively easy to do. But in the case of unschedulable pods, those are pods that the Kubernetes scheduler cannot find a node for. There's nothing that fits. This is where Carpenter can look at the node pool and say, all right, is there anything in the recipes that I know about that will allow me to make a node that will fit this pod? And then, if it finds that, then it will make a request to the provider saying, here are kind of the constraints and requirements that I need from this node pool. Can you make me one? And it'll do that. And so this is just to kind of set the ground floor for where we're going to go next. So next slide, please. All right. So this is not a strict sequence diagram. This is more of like a diagram to show the functional relationships between the different pieces of, kind of Carpenter and cluster API. And so on the upper left corner, you see the node pool. And the node pool is a CRD that's associated with Carpenter. This is kind of the basic unit for how you kick things off. This is how you tell Carpenter that, okay, this is what this node pool can do. This is how you should make nodes that come out of this. And then assuming that, that all looks good and everything, when Carpenter wants to create, scaling events in the cluster, it creates what's called a node claim. And this is the other big CRD that comes out of Carpenter. And a node claim, kind of has a linkage about some constraints and the requirements that are needed to be created. And that gets reconciled then again. And you can see this like dotted line around the Carpenter core and Carpenter cluster API. That's just to signify that these are all part of the same pod, but they're like different code pieces. And so in our case, when we see a node claim come in, we would evaluate that node claim, and and if we can, we'll make a machine from that. And so we'll inspect the node claim, and then there are some decisions that need to be made, and then we will make a machine to go with that. All right, so next slide, please. So this is getting into the custom resource relationships. And so on the left-hand side, you see the node pool and the node claim. And those are the two important ones that come from Carpenter. And what, I've put some like little ... here. There is other information. The node pool has all sorts of information that you can specify kind of, the requirements and the constraints around how nodes are created there. There's information a user could put there about like kube configs that you would like to see expressed, labels, taints that you would like to see put on the nodes that are created. So there's a whole bunch of information there. Similarly with the node claim, the node claim has like requirements around what needs to be fulfilled from the cloud provider to satisfy the claim for the node. But in both cases, the important part and the detail that's important for us is they have a reference, an object reference to something that they call the node class. And the node class varies by provider. So, if you were on AWS or Azure, you would have an AWS node class or an Azure node class. I think on AWS, it's called like the EC2 node class. And I'm not sure what the Azure one is called, but for us, I'm proposing, a cluster API node class. And the way that this would work for us, and this, if you've been at meetings recently, I've been asking questions about infrastructure, machine templates or whatnot. But for us, a node class is how we understand what type of instances to create to satisfy nodes. And so the way we're kind of approaching this is that there will be a machine template reference here that points to like the template for the instances that could be made. And then a bootstrap config so that we can combine those two things together to make an instance, and then some set of labels, right? So the labels will help us then to create a filtered list of machine templates. So you can imagine a user would be creating machine templates in their cluster. For example, if I'm doing this with the kubemark testing, which is where I'm kind of doing this, I'm creating kubemark machine templates in my cluster. So thank you, Stefan. Machine template means infrastructure machine template here. But in the case of our node class, what we do is as a user, I might make a bunch of kubemark machine templates to signify different instance types that I'd like to make. And then I would add labels to those, and I could use the labels in the node class then to create this filtered list of machine templates. And then ultimately, one of the things that we're really curious about getting the machine template for is so that we can get the capacity of that node type that would be created from it. And so this is kind of what the class relationships are looking at. And what I'll get into next is kind of, we will look at a sequence diagram. Next slide, please, Fabrizio. So now this is a sequence diagram, but I haven't put like every single thing on here. What I've tried to do is highlight interactions that I think we need to be concerned about from a community perspective to understand how this works. So imagine, if you will, this is kind of like a generic node creation process. So there are pods that are pending or unschedulable in Kubernetes. And the Carpenter, core kind of recognizes this. And so it says, all right, one of the things I want to do is get the instance types that are known from the provider, because it needs to know what instance types are available that it might be able to mix and match with. And so for us, from the Carpenter CAPI perspective, this is where we do the listing of the machine templates based on the labels and the references from the node class, because the node class is something that we'll have access to here. And then presumably a group of templates come back from Cluster API, and we then convert those templates into the constraints and capacity requirements that need to get filled in for the instance type structure to pass back to the Carpenter core. And this is, I highlighted this because I think this is going to be really important to us to understand like where this information comes from and how we can keep it up to date. So next slide, please, Fabrizio. So this is a continuation of that process. So you could imagine now, like, let's say that, okay, Carpenter says, all right, I figured out what I want. It makes a create call with the node claim in question. And this is where we're looking inside the node claim. We're pulling out the node class to figure out what instance types are available to us. And then we're going to choose the correct template based on those requirements. Now, this is where the Carpenter CAPI provider has a little bit of leeway here. It can choose the cheapest instance if it knows what it is, or it could choose the one that's the minimal size that fits. Or, there's a little bit of option here into how the provider, chooses which instance to create. But theoretically, it finds an instance to create, and then the Carpenter provider calls out the cluster API and makes a machine, right? So in this case, it makes basically an orphan machine using the infrastructure machine template and the bootstrap configuration from the node class that it had. Then the next task that the Carpenter provider needs to do is that it's going to need to reconcile on machines to make sure that node claim statuses are updated so that the core Carpenter kind of knows how those nodes are transiting through the process of going from creation to actually becoming a node in the cluster. So next slide, please, Fabrizio. So there were some alternate ways to do this. And one of the ones that, we had a lot of discussions in the feature group about was, why not use like machine pools or deployments or machine sets? Why not use any of the scalable resources that we already have, like the cluster autoscaler does? And, in discussing how Carpenter works and kind of the best ways to get performance out of Carpenter, we thought that, one of the things is it creates a very cumbersome user experience to manage all these different scalable resource types. And then, more additionally, it becomes really complex to track like what is happening with those scalable resources. And this is, from the code perspective, it becomes complex to track what's happening. But then even more like for the user, it's not clear what Carpenter is doing at any moment because you need to inspect the machine, the scalable machine types to figure out how it's scaling and what it has created. And so, after we talked about this for quite a while, we thought that for the initial proof of concept, let's just make orphan machines, and maybe we'll do something where we have them be owned by, maybe they'll be owned by the cluster object or something. We're still kind of working through some of those details, but we did spend a lot of time talking about, the scalable resources and everything. And this was kind of like the main other alternative that we had discussed. Although we did discuss the options of using the, just kind of like the regular implementations of Carpenter, like Carpenter AWS, Carpenter Azure. But one thing we agreed on in the feature group is that we wanted to preserve as much of the cluster API experience as possible so that users, who are coming to this from a cluster API perspective, they're still seeing machines appear in the cluster. They're still, able to interact with them by updating infrastructure templates or creating new infrastructure templates, those kind of things. So that, we did kind of look at some of these. And then finally, next slide, please, Fabrizio. Out of all this, as I've been kind of hacking on the code, I came up with a user story in mind that I wanted to bring back to this community. And I know we've talked about this a little bit, but like this was the user story that is most prevalent in my mind when writing this provider. So as a Kubernetes developer, writing predictive scaling applications that use cluster API, I would like to be able to know what a node will look like before creating a machine so that I can make better decisions about the infrastructure resources. And if there was some way to, cluster API had an interface for determining the node shape, that would absolutely solve my problem. So that's pretty much the end of the slide deck. I guess like at this point, like the POC is not ready to be demonstrated yet. Like there's still work that needs to be done, but yeah, this is kind of the direction we're going. And I wanted to, as my questions in the last few weeks have kind of, illuminated or whatever, or implied, this is kind of what we're hacking on at the moment. So I guess any questions or comments?
Stefan.
I'm mostly wondering how much we're losing by not using stuff like machine deployments and machine pools that are well integrated. So the things I was thinking about is one thing, in which way is the Kubernetes version represented? And how does Carpenter know with which version to create a machine? And also how, just open questions. I don't expect solutions at this point.
Yeah.
Also, how would it work together with cluster deletion? That might be relatively easy if it's just, a machine is just child of a cluster, and then during cluster deletion, we just delete all the machines.
Right.
Cluster upgrade might be more tricky. Basically, how does the user trigger cluster upgrades? Are they just modifying machines in place? Do they have to create new machines? Is Carpenter somehow doing the upgrade? And also, cluster class could be very, very tricky because it basically works on the assumption that it knows what machines and nodes you have in a cluster, and then when you have an upgrade, and upgrades them one after another. I'm
Right.
not sure how this
And-
would work with standalone machines, basically. But I mean, just open questions.
Yeah, no, I mean, they're great
Question.
questions, Stefan. And like some of those things I want to push deeper to figure out, like, because Carpenter has great abilities for like, detecting version skew in the cluster and like performing through disruption, things like cluster upgrades and whatnot. So if there was some way to kind of like bridge that gap, to make it transparent, it would be really cool to be able to allow, Carpenter to kind of push that forward and say, okay, we can let Carpenter manage the Kubernetes upgrade using, just the components coming out of the cluster API bits. But to back up just a little bit, when you were asking about the version, what you were saying, how does it know which version of the machine to make? Or
Yes. What I mean with merge, I mean, you have the infra machine template, you have the bootstrap config template. And if you look at a machine object, that's almost everything, but there's also a spec version field in there. And I wonder how Carpenter picks that. Or how Carpenter
for the
would pick that.
Kubernetes version?
Kubernetes version, yeah.
Yeah, I guess we'll have to figure out some way to kind of, to figure out how to make that work. I haven't really hit that speed bump yet.
If I might add on this line, there is not only a Kubernetes version, there are also things like
labels on
node drain, a set of parameters about how to do node drain on top of my mind. And also there are things like tailor domains that we have to figure it out. There are things like label propagation. So I let me say, when I was looking at this picture, I went back to this slide. So, or we can even go back to the previous one. Sorry, let me click. So this one. So at the end, one of the cool feature of one of the many cool feature of Carpenter is that it can mix and match different type of machines. And in mine, I have to admit I never looked into this like you did, but in my naive way of thinking, I was imagining something like Carpenter controlling one or more machine deployment or one or more machine pools. So basically you use existing primitive to define machine types, to define everything that goes around end-to-end or everything that goes around the machine. And Carpenter basically takes ownership of these machine deployment, machine pools, et cetera, and act instead of the user. Is like what we are proposing here, but instead of having a machine template list, you will have a machine deployment list or a machine pool list. And so basically you can inherit whatever, not only machine template, bootstrap config, but also labels, also node drain, and also Kubernetes version from the existing abstraction. But Carpenter, basically, it is the higher level controller on top of them. And but this is my naive way of thinking, but apart this, which is total brainstorming from me, is I really thank you and the folks in the working group. We really like this kind of communication, feedback, interaction with the work group. Thank you very much.
Yeah, thanks, Fabrizio. And I see Lubomir's hand up, but before we go to Lubomir, I just want to say, like, it's not naive thinking at all, because like even like last year when I was looking at the Carpenter project, that's where I started too. I was like, we could just make Carpenter like the cluster autoscaler. We could just have it manipulate scalable types, like machine deployments and call it a day, right? We can just have it, bump the replica counts and all that other stuff. But as we started to investigate how to do that with Carpenter, it started to make less and less sense because of how Carpenter expresses the node claims. And so it started to make more sense to us just to say, for the proof of concept, let's just try and make these orphan machines and see what happens. And I think, it might be worthwhile at some point to come back to that decision and say, okay, maybe it makes more sense to use like machine deployments or machine pools or something. But You know, yeah, like we're just kind of here because of, I guess, organic evolution of how we got here. Lubomir, please.
Yeah, my comment is not so much about the intricate details of the implementation. It's so much about more about the discussion we had with the leads of Cluster Lifecycle at some point that maybe we should create a API review process, which basically implies that if we have something like this, okay, this is obviously something new. Maybe we can just, everybody who has bandwidth can jump on the proposal. Hopefully, you know, it's something like a cap or a KIP,
Yes.
where we can comment. And Vince can join, and everybody can potentially find the time to review the API.
Yeah, absolutely, Lubomir. My intention, and I think where we're going with the feature group, and I think we stated this, but I'm not sure. But yeah, my intention at the end of this proof of concept work is to propose an enhancement proposal back to Cluster API so that we can do a full review on the API types and the mechanisms and everything. So I think, yeah, like even though we're going to create this code and it'll be kind of experimental and hopefully will work at some point, yeah, eventually it'll come back to an enhancement. And before we kind of solidify on this, I absolutely agree with you. I would like to get a wider review on the API, make sure it makes sense and everything.
Have you seen something like a high demand for a pressing API release around this integration? Like
I wouldn't say pressing. I think there's a lot of interest that I'm registering from various parts of the community, and right now people are basically like, "Hey, I'd like to see," you know, people are kind of like, "I'd like to see it work," you know. So I don't think there's really a pressing need to get this out the door. I think, I mean, my personal opinion is we can take our time to design this properly and let's make it in a way that makes sense because, you know, the user story that I ask at the end, I think is going to be a very big ask for the CAPI community if we want to make this like really good.
And this is going to be very flexible in terms of user and customer demands, whether they want to target specific groups of nodes. And yes, I think this is really good. Just one concern is that if CAPI doesn't have bandwidth to review the API, then Carpenter could potentially release with the experimental API, which you know, maybe it's not something that we want. But hopefully we have the bandwidth and we can proceed with a good review and get this solidified.
Yeah, absolutely. And just on the notion of APIs, before I jump to Jonathan here, going back to a question that Stefan had brought up about, and you know, Fabrizio kind of talked about it too, about like Kubernetes versions and specific options and whatnot. The node class might be the place that we end up like kind of stuffing all those things to give the user the way to express like, okay, what is being created out of this? But I remember that from previously. Jonathan, please.
Yeah, first of all, this is really cool. I'm really excited to see like once we get like a working POC, I think that'll be really, really cool to see. So thanks for doing work on this, Mike. I think it's been nice, like seeing this come to fruition. I had a couple thoughts. So I think the first one is, so the node drain behavior, I'd be interested to collaborate on that. Like if y'all have thoughts around node drain behavior, just because like the way the Carpenter reasons about, and also for context for everyone, I'm a Carpenter maintainer. So part of the reason I was here is because I was interested in this demo. But Carpenter already reasons about and has an opinionated stance on how it reasons about draining behavior. But this is something that we're talking about actively with Cluster Autoscaler around like how we think like we can unify the experience around how we should orchestrate draining behavior. Maybe some of this has overlap with the node maintenance cap that's been open for a while, and kind of just like merging thoughts around how users can configure this to upstream. But I think we should discuss that more. It'd be interesting to hear like how CAPI reasons about it because I'm not familiar with it, and seeing if there are ways to align all these things across everywhere. And then I'm trying to add one other thought, but I forgot what it was. So if I remember what it is, I'll come back to it. But anyways, this is cool to see.
Cool. Thanks, Jonathan. And yeah, happy to sync up about the node drain stuff. Like it'd probably be an education for me as well, because I can't say that I know how Cluster API does it like off the back of my hand or whatever. So just as a final wrap up to this, as I see the hands raising has slowed down, I'm going to turn this presentation into a PDF, and I will check it into the repository that I've been, putting together for the Carpenter provider. I've got like a documentation site that I'm working on setting up for that. So like, I'll just kind of include it with everything there. Stefan, please.
Yeah, I just want to bring up one point I put in the chat. I wonder if machine pool could be a relatively well fit in a sense of it's already a very freestyle object, to be honest. I mean, basically, if you look at machine pool across providers, as far as I can tell, basically, you have your core copy machine pool object. The controller is not doing much. Then you have your infrastructure object. The infra provider is just doing whatever. The main difference is maybe just that, I mean, definitely a main difference is that in the Carpenter case, the machines can look vastly different. So they're not just all the same of one machine pool. But if there is basically a need still to represent like a group of machines for Carpenter machines, maybe machine pool is relatively well fit for that. I don't know, just an idea.
Yeah, no, I mean, it's a great idea. Like, and this, I think a couple months ago, we talked about this at a Cluster API office hours, like kind of the limits of, could we have heterogeneous machine pools and those kind of things. And so, yeah, like I love like hearing those ideas. Like I'm happy to kind of collaborate on any of this stuff. Like I think part of the reason I wanted to bring this back to the community, and thank you to everyone who was kind of like, hey, can we get a look at this? Because I think it'd be great to figure out like what does the community want to see, right? Like something that came out of the feature group, one of the really high priorities that came out of the feature group is we want this to be a Carpenter experience, but we also don't want to break users' expectations around Cluster API. We want people to have a good Cluster API experience. And so if we as a community think like, hey, orphan machines don't make sense, maybe it'd be better for these to be in machine pools. And maybe that means we need to change the spec for the machine pool a little bit to help aid this. Like, yeah, I'm totally totally happy to like, collaborate in that direction. I think these are great ideas. I appreciate it, Stefan. Jonathan, did you raise your hand again? You remembered?
I did. I remembered. I was curious because I remember that on one of the feature group discussions, we had a little bit of talking about how the Carpenter instance actually get managed in the infrastructure cluster or in the CAPI cluster itself. I'm assuming, just because I'm not super familiar with the pattern, like with cluster autoscaler, you basically just have a bunch of cluster autoscalers that are running in the admin cluster, and then those are responsible for scaling each of their individual clusters they point at. Is that the same idea that Carpenter is basically going to be like, its cube config is going to be pointing at a given cluster, it's going to be running in the admin cluster, it's going to be responsible for scaling its machines that it owns and its clusters? Okay, that's the...
Yeah. It's not the only topology, but I would say there are several topologies that are very common in Cluster API. And one of the most common ones is to have, a management cluster and then several like workload clusters, right? And yeah, like we've heard, from many users who like to run the cluster autoscaler, like each cluster is namespaced on the management cluster, and then they run a cluster autoscaler in each namespace so that it can see, the cluster API objects in that namespace. And then it can also talk to the workload cluster to get pods and nodes. And so one of the ways that we've been thinking about Carpenter is it would be nice to operate Carpenter in the same way, where like you could have a namespace, the node pools and node claims are all in that namespace with all the cluster API objects like machines and whatnot. So that's isolated on the management cluster. And then, the nodes and pods come from the workload cluster. And I started to get into this multiplexing client kind of stuff, but then I noticed that Stefan Szymanski is doing some work in controller runtime to make a multi-cluster aware client. And so I think if we can draft off some of that work, I think that'll be a really big deal for making this work the way we want it to.
Yeah, I'd be interested in hearing that. I actually wasn't aware of that, so that'd be super cool to see. Yeah,
Yeah.
I guess the other follow-up question of that is like you have the same problem with CAS, I assume. Like, what's responsible for managing the infrastructure that runs those things?
Right.
Right. I don't know, was there ever like a closure on that, or was it just like you have to kind of manually manage the infrastructure yourself?
Well, yeah, like we provide several options on the cluster autoscaler for how users can configure it. So yeah, like they, you know, either they're running the management cluster on their own, or they've created it on their own, or they could run cluster API in what we call a joined cluster, you know, where like the management bits are all in the workload, you know, so it's all one cluster. If that's what you were meaning.
Yeah, I think that answers it. Cool. Thanks.
Okay, cool.
Thank you. Just we give Jake the time to speak. Then it is 5 minutes to the end of the meeting. So okay, go Jake.
I think my remark is actually non-essential, so I'll let us move on. I'll chat with Mike and Jonathan.
Okay, so I stop sharing. Go back to the agenda doc if I can find it again. Okay, it is here. So first of all, quick note about what Lubomir was saying. I think that this is one of the most exciting things happening in CAPI. So I'm pretty confident that if we have a proposal, something to rally on, we'll get there. But yeah, let's see how it goes. Next up in the agenda is a very quick one from me. There is a feature group, which is alternative communicator pattern, which is pretty inactive since a long time. Yeah, I'm reaching out to the owners to see if they are still interested. Otherwise, I think we should retire it, just for clarity with regards to the community. Lubomir?
Yeah, also I don't know, maybe 4 months ago or something, maybe end of 2023. I also asked the question what's going on with the in-place upgrades feature group, and I think it's also completely inactive, if I'm not mistaken.
That's so it is. I was chatting with Guillermo, which is one of the members of the. He has a document, but it's pretty, which is moving on. This document has been shared around from some time. So at least there I saw some programs in the last couple of months, while for this one not. So this is why I'm raising the point. Okay, thank you, Lubomir, for the thumbs up. We can quickly move to provider updates. First one is Christian.
Yeah, really quick. We released v1.10.0 for CAPV today, which includes CAPI v1.7.1 support and Kubernetes 1.30 support. That's really it.
Thank you very much. Next up, Nolan.
Yeah, there was a release, patch release for Kappa 242 a couple weeks ago. I just don't think we mentioned it here. And then we're looking to get 2.5 out with some telco features and CAPI 1.7.1 this week.
Cool, great. Great to see progress and also on Kappa. Jonathan.
Hi, yeah. I released the v0.2.2 version of CapH last night, and that should hopefully fix the metadata.yaml issue that some people are having trying to upgrade. So
yeah,
if anyone was blocked on that, hopefully this should fix it, and let me know if there's anything that needs any more work.
Thank you. Thank you very much for jumping on this, and great work on CapH as well. So before dropping, I would like also to bring up that controller runtime new version has been released. And I would like to take the opportunity to give a huge shout out to Stefan, Alvaro, Vince, all the folks that are maintaining controller runtime, which is the building block that almost every cluster API provider rely on. So thank you very much, and folks, please start planning to bump to the new controller runtime release. And if there are no other Stefan.
One very quick note. We are implementing more and more generics in controller runtime. So if you like that, bump. No, basically, as of today, you can use with the new release generics for predicates, for event handlers, for one or two other things that I'm missing. And also Alvaro did some PRs against KK that merged today to also implement generics for work queues and this sort of stuff. That didn't make it in a control runtime yet, but we introduce more and more generics so that we're getting rid of a lot of this. Oh, here's an object. Let's figure out if that object is actually a machine because that's everywhere.
Lubomir, 30 seconds left.
Do you have benchmark checks in the introduction of generics?
No, but it's additional and optional, so you're not forced to use it, at least.
Okay, thank you.
Thank you very much, folks, especially Mike, for the great discussion. See you next week.
Thanks, Fabrizio.